Meet Mark. Mark is a student at Northwest Missouri State University where he gives campus tours to visitors and their families and studies biology. In 2009, Mark was diagnosed with epilepsy. With this diagnosis, his life was changed forever.
It was a shock, from not being an epileptic to all of a sudden having a diagnosis that didn't know much about. It's odd. Regular epilepsy, there's just things you have to stay away from and things you have to be aware of all the time. So, for example, staying up late is a bad thing. Not eating meals is a bad thing. Alcohol in excessive amounts is also not very smart. My first seizure happened actually at a friend's house, and we had been staying up late playing video games like all friends do, but ambulance guys come and tell me that I probably had a seizure.
Neurotoxins produced by spiders and other animals may hold the key to creating new medications for disorders like epilepsy. The Molescu Lab at the University of Missouri is at the forefront of research using spider toxins to study the nervous system.
I am Atusa Solari, and I'm a PhD candidate here at Mizzou in the Biological Sciences Department. So I specifically study ion channels, in particular voltage-gated ion channels. And these are proteins, or you can think of them as molecular machines that are within the nervous system and control a lot of things that we do, from breathing to moving and talking and so on.
Ions are charged particles that flow through ion channels. This flow of charge is what allows our nerves to conduct electrical impulses in the same way that wires do. Toxins interfere with this process in several ways, the simplest of which is simply by plugging the ion channel's pore. This behaves just like a cork in a wine bottle and stops the flow of charge through the channel.
So we know that venom from animals are going to target ion channels, and I use specific toxins to look at specific kinds of ion channels. The idea is, if you think about two different extremes, if you think about a network of neurons that is really overexcitable versus a network that is not excitable enough, you can use toxins to essentially restore the normal behavior. I think an important thing to realize is that we have a lot of different types of ion channels, and medication, of course, needs to be as specific as possible. So we know these side effects, right? These kind of off-target effects. And I think the importance of what we do medicinally is to really find the most specific interaction between one type of channel and one type of toxin. And that way we can alleviate symptoms without too many off-target effects.
Every day, researchers at the University of Missouri's Molescu Lab are breaking new ground in our understanding of the brain. Each discovery can become a new tool to help people with disorders like Mark's live fuller and happier lives.